Electrical codes for the entertainment industry are crucial for ensuring safety in venues. The National Fire Protection Association, or NFPA, provides several key standards. NFPA 70, also known as the National Electrical Code or NEC, contains general electrical safety requirements applicable to entertainment venues. NFPA 101, the Life Safety Code, specifies safety requirements for public assembly facilities, including entertainment venues. NFPA 79, the Electrical Standard for Industrial Machinery, addresses electrical safety for equipment used in entertainment, like motors and controls. The American National Standards Institute, or ANSI, also offers relevant standards. ANSI 1.11 covers entertainment technology, specifically electrical power distribution and control standards, providing guidelines for these systems in entertainment venues. ANSI 1.12 addresses entertainment technology, focusing on permanent electrical installations in spectator seating areas, covering electrical requirements for permanent installations such as stage lighting and sound systems. The Entertainment Technician Certification Program, or ETCP, offers a certification program for qualified electrical technicians working in entertainment. The ETCP Certified Entertainment Electrician, or C, which includes knowledge of electrical codes and best practices. It's essential to consult local building codes, as most municipalities and counties have codes that incorporate or reference the national and industry standards mentioned. The International Electrotechnical Commission, or IC, publishes international electrical standards, including IEC 60050, which covers electrical safety for theatrical equipment. The Entertainment Industries Council, or IC, develops and promotes safety standards for the entertainment industry. The Electrical Safety Foundation International, or SV, provides electrical safety education and resources for the public and industry professionals. Exploring the National Electrical Code, it's important to understand its structure and how it applies to entertainment venues. The NEC is organized into chapters, articles, and sections covering various aspects of electrical installations. Chapter 1 covers general requirements, including definitions, scope, and rules for electrical installations. Chapter 2 deals with wiring and protection, including overcurrent protection, grounding, and wiring methods. Chapter 3 covers wiring methods and materials, specifying acceptable types of cables, conduits, and other wiring components. Chapter 4 addresses equipment for general use, covering requirements for luminaires, appliances, and other electrical equipment. Chapter 5 focuses on special occupancies, including theaters, motion picture and television studios, and similar locations. Chapter 6 covers special equipment, including electric science, elevators, and data processing equipment. Chapter 7 addresses special conditions such as emergency systems, hazardous locations, and critical operations power systems. Chapter 8 deals with communications systems, including telephone, data, and cable television systems. Chapter 9 contains tables and examples used for calculations and reference. When applying the NEC to entertainment venues, pay close attention to Article 520, which specifically addresses theaters, audience areas of motion picture and television studios, and similar locations. This article provides requirements for wiring methods, stage lighting, control systems, and other electrical equipment used in these venues. Also consider Article 530, which covers motion picture and television studios and similar locations, providing requirements for stage lighting, sound systems, and other electrical equipment used in these studios. It's important to ensure that all electrical installations comply with the applicable requirements of the NEC, as well as any local building codes or regulations. Grounding and bonding are critical aspects of electrical safety in entertainment venues. Proper grounding helps to minimize the risk of electric shock and prevent equipment damage. The NEC provides detailed requirements for grounding and bonding in Article 250. Grounding refers to connecting electrical equipment and systems to the earth, providing a low impedance path for fault currents to flow back to the source. Bonding refers to connecting non-current carrying metal parts of electrical equipment and systems together, creating an electrically continuous path. The main grounding electrode should be a metal underground water pipe, a ground ring, or other approved grounding electrode. The grounding electrode conductor connects the grounding electrode to the equipment grounding bus in the electrical panel. Equipment grounding conductors are used to connect non-current carrying metal parts of electrical equipment to the equipment grounding bus. Bonding jumpers are used to connect different metal parts together, ensuring electrical continuity. In entertainment venues, it's especially important to properly ground and bond stage lighting equipment, sound systems, and other electrical equipment. Portable electrical equipment should be grounded using a 3-wire cord and plug. All metal parts of the stage structure should be bonded together. The NEC also requires the use of ground fault circuit interrupters, or GFCIs, in certain locations, such as wet locations and areas where portable electrical equipment is used. GFCIs are designed to detect small ground faults and quickly disconnect power to the circuit, reducing the risk of electric shock. Overcurrent protection is another essential aspect of electrical safety. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect electrical circuits from overloads and short circuits. The NEC provides detailed requirements for overcurrent protection in Article 240. Overcurrent protection devices must be sized appropriately for the circuit they are protecting. The ampacity of the conductors in the circuit must be considered when selecting the overcurrent protection device. Overcurrent protection devices must be readily accessible and properly labeled. In entertainment venues, it's important to provide overcurrent protection for all electrical circuits, including stage lighting circuits, sound system circuits, and general-purpose circuits. Stage lighting circuits often require the use of specifically sized fuses or circuit breakers to protect the lighting equipment. Sound system circuits may also require the use of specifically sized fuses or circuit breakers to protect the amplifiers and other equipment. Portable electrical equipment should be protected by fuses or circuit breakers in the electrical panel or by using portable GFCI devices. Wiring methods and materials are also important considerations for electrical safety in entertainment venues. The NEC specifies acceptable wiring methods and materials in Chapter 3. Wiring methods include conduit, cable, and other types of raceways. Conduit is a rigid metal or plastic tubing used to protect electrical conductors. Cable is a factory assembly of 2 or more insulated conductors. The type of wiring method used depends on the application and the environment. In entertainment venues, it's important to use wiring methods that are suitable for the environment and that can withstand the physical stresses of the venue. Flexible metal conduit, or FMC, is often used for wiring stage lighting equipment. Cable trays are often used for supporting cables in large entertainment venues. All wiring must be properly installed and supported. Conductors must be protected from physical damage. The NEC also requires the use of specific types of conductors for certain applications. For example, conductors used in wet locations must be listed for wet locations. Conductors used in high-temperature locations must be listed for high-temperature locations. Electrical safety training is essential for all personnel working in entertainment venues. Training should cover the basics of electrical safety, including the hazards of electricity, safe work practices, and the use of personal protective equipment. Personnel should be trained on how to identify electrical hazards and how to avoid them. Training should also cover the proper use of electrical equipment, including stage lighting equipment, sound systems, and other electrical devices. Personnel should be trained on how to inspect electrical equipment for damage and how to report any problems. Training should also cover the proper use of personal protective equipment, such as gloves, safety glasses, and insulated tools. Regular refresher training should be provided to ensure that personnel stay up to date on electrical safety practices. The Entertainment Technician Certification Program, or ETCP, offers a certification program for qualified electrical technicians working in the entertainment industry. This certification program includes training on electrical safety and best practices. Regular inspections and maintenance are also important for ensuring electrical safety in entertainment venues. Electrical equipment should be inspected regularly for damage or wear. Wiring should be checked for loose connections or frayed insulation. Overcurrent protection devices should be tested to ensure that they are functioning properly. Grounding and bonding connections should be checked for corrosion or damage. Any problems should be corrected promptly. A qualified electrical contractor should be hired to perform regular electrical inspections and maintenance. The electrical contractor should be familiar with the NEC and other applicable standards. The electrical contractor should also be experienced in working in entertainment venues. Emergency procedures should be in place in case of an electrical accident. Personnel should be trained on how to respond to an electrical emergency. The emergency procedures should include steps for shutting off power to the affected area, providing first aid to injured persons, and contacting emergency services. Emergency contact information should be posted in a prominent location. A readily available fire extinguisher should be nearby. A fire alarm system should be tested regularly. Proper planning and design are crucial for ensuring electrical safety in new entertainment venues or when renovating existing venues. A qualified electrical engineer should be involved in the planning and design process. The electrical engineer should be familiar with the NEC and other applicable standards. The electrical engineer should also be experienced in designing electrical systems for entertainment venues. The electrical system should be designed to meet the specific needs of the venue. The electrical system should also be designed to be safe and reliable. The electrical system should be properly documented. All electrical plans and specifications should be reviewed and approved by the local building department. By following these guidelines, you can help to ensure electrical safety in entertainment venues. This will help to protect the safety of performers, crew members, and audience members. Electrical safety is a shared responsibility. Everyone who works in or visits an entertainment venue should be aware of the potential electrical hazards and take steps to avoid them. The NEC is updated every 3 years, so it's important to stay current on the latest requirements. The NFPA and other organizations offer training courses and resources on electrical safety. By working together, we can create a safe and enjoyable environment for everyone in the entertainment industry. The electrical system should be designed with future needs in mind. It is generally better to oversize the electrical system to allow for future expansion. This will avoid the need to make costly modifications to the electrical system later on. The electrical system should be designed to be energy efficient. This will help to reduce operating costs and conserve energy. Energy-efficient lighting and other electrical equipment should be used. Consider the use of lighting control systems to reduce energy consumption. The electrical system should be designed to be easy to maintain. This will help to reduce maintenance costs and ensure the long-term reliability of the system. The electrical equipment should be readily accessible for maintenance. The electrical system should be properly labeled. All electrical panels and circuits should be clearly labeled. This will make it easier to identify and troubleshoot problems. The electrical system should be properly documented. All electrical plans and specifications should be kept in a safe place. The documentation should be updated whenever changes are made to the electrical system. Consider arc fault circuit interrupters, or ANSIs, in addition to GFCIs, especially in areas with sensitive electronic equipment. ANSIs are designed to detect arc faults, which are a common cause of electrical fires. Arc faults can occur when there is a break in the insulation of a wire or when there is a loose connection. ANSIs can help to prevent electrical fires by quickly disconnecting power to a circuit when an arc fault is detected. Use surge protection devices, or SPDs, to protect sensitive electronic equipment from power surges. Power surges can be caused by lightning strikes, power outages, or other electrical disturbances. SPD can help to protect electronic equipment from damage by diverting excess voltage to ground. Consider the use of uninterruptible power supplies, or UPSs, for critical equipment. UPS provide backup power in the event of a power outage. This can help to prevent data loss and other problems.